And otherwise, we're going to move on to our final presenter here. And we also just want to thank Dave Hill for providing an update and insight into one of these multiple exciting, interesting companies that are going forward in the molten salt space. You guys really give me inspiration when I get to listen to all of you one after another. Okay. And so we'll turn it last but not least, we have Mark Perez from Kairos Power, and we will turn this over, the floor over to him and let him share his vision for the future.
Thank you, David. Appreciate the opportunity. Just a little introduction. My name is Mark Perez. I'm the Vice President of Engineering for Kairos. I've got 40 years in the nuclear industry. I was lucky enough to start in 1981 at the Fast Flux Test Facility as an operator. I was there from right after initial critical until 1993, learned all about the plant, moved up to shift manager, and I gave the order to reduce power from 100% the last time that reactor ran. I ended up spending 30 years at Hanford. I had a number of different opportunities there. One of them was to be the manager of the B reactor, which is the first full-scale reactor where Enrico Fermi discovered xenon poisoning. And I'm reminded, I got to open up that as a National Historic Landmark for public tours. But I'm reminded of what we can do if we put our mind to it. They broke ground on that reactor in October of 1943, and it went critical in September of 1944 and ran for 26 years. Got to do a few more things at Hanford. I constructed a new liquid waste treatment facility. Also was in charge of the spent fuel cleanup project, which at one time had 80% of DOE's radionuclides. And then decided I wanted to dedicate what I had left of my career to commercial nuclear power, because I passionately think it's important for us. I spent 8 years on the NuScale project. I was responsible for engineering to submit the design certification that was just approved. And then in May of 2019, I moved to Kairos. And this is the best job I've ever had. Some of the things I'm going to show might be a little bit redundant to what Peter Hastings presented yesterday, but at the risk of redundancy, for those who may not have been here, I'll maybe gloss over those quickly. I can advance my screen. So Kairos Power's mission is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment. Important mission. I think probably everybody on this call, this workshop has the same kind of feeling. In order to achieve that, we realize that we have to provide technology that's affordable and safe. Overview of Kairos. Pretty new company, founded in 2016. We've ramped up to 158 employees, very engineering focused. We're privately funded and schedule driven to deliver a demonstration plant by 2030 or earlier. We also are very cost conscious and realize that we're going to have to compete in an aggressive marketplace. So Kairos is Greek for the right or opportune moment. And the founders recognized that this incredible peak of natural gas build out in the early 2000s was going to result in another peak of generation retirements, probably around 2035 or so. And we want to have a technology that's ready to answer that upcoming peak. We also realized that we have to be aggressive in and compete with natural gas basically today. Things don't change in tough market conditions. So we're targeting at least a competitive dispatchable target of $50 per megawatt hour. And we think we can do maybe a little bit better than that, probably in the nth of a kind. Our technology is based on particle fuel, TRISO, FLIBE coolant. And then I love this picture because that's my FFTF core before it was filled with sodium. But those two, the fuel and coolant combination allows us to have a functional containment so we can have low pressure reactor vessels, low pressure systems and we can avoid costly containment structures. We've done quite a bit of design work on the full-scale reactor, which would be a 320 megawatt thermal, about 140 megawatt electric. We haven't really designed all the BOP yet, so we don't quite know all of the parasitic loads. 100 degrees C delta T with an outlet of 650, probably about 6 inches of water or so, cover gas pressure, and we need HALEU fuel. So the main focus of all that we do is to build cost certainty. And in order to build cost certainty, we think we need technology, licensing, supply chain, and build certainty. And from that, we build our work streams to Kairos, which are the design, test, licensing, fuel development, salt development. So our system involves this sequence of non-nuclear development facilities: the rapid analysis prototyping iterative design lab, or R lab, salt handling lab, or S lab, the component testing facility, or T facility, which would be full-scale components, and then the user facility, or U facility, which we plan to be a full-scale replica of our commercial nuclear primary system, including the civil structural. So what we've done so far, Alameda headquarters in California, is a 70-some-year-old airplane hangar that we refurbished. There's a couple of pictures of what it looked like. And we built it into a really cool office and lab complex that's shown on the right, and moved in there in September of 2018. Our rapid lab was commissioned in the fall of 2018. On the left shows a picture from the top floor of the office that looks out over the kind of a testing floor with some manufacturing. We've got our ETU demonstration experiment, which is in the pink structure down on the lower left. I'll talk more about that. There's a little salt loop down on the lower right, and a couple other experiments that we do out in that area. And then on the right, we've got some scaled, mostly thermal hydraulic, but water and oil scaled experiments that have been working over the last couple years. So the Etude is the engineering test unit demonstration experiment, and it's a scaled water mock-up of our engineering test unit, which I'll talk a little bit more about. It includes a pump, pebble circulation system, control rod insertion, and there's a picture of the scaled reactor vessel. Of course, it's non-nuclear for ETU, but this is where we're experimenting with how to insert pebbles and how to withdraw pebbles, how rods will be inserted, and then how the pump's going to work. Some recent progress. In September of 2020, we commissioned, and this was somewhat delayed because of COVID, but we commissioned and put into operation our salt lab. We've been very fortunate to ride through the COVID experience without any, actually with increasing staff pretty steadily, and with very little disruption. And we are now melting FLIBE in the S lab in Alameda. And then on the right is our New Mexico expansion. We call that KP Southwest. And this is a 110,000 square foot facility that was going to be a solar panel manufacturing facility that never got off the ground. But we are looking to develop quite a bit of vertical integration manufacturing within this facility. We've started to put into place graphite manufacturing here, graphite machining, and we just broke ground on construction of our T facility, which will be an adjacent, kind of an annex to this facility in New Mexico. So Kairos Power is taking a different approach to nuclear. We think nuclear has to be done really kind of drastically different than it has in the past. And in the past, we've had long development cycles where you kind of make a lot of paper that gets increasingly more complex and intricate and harder to change. You know, you probably hook up with an EPC sometime after you've got almost designed, close to finished. You find out that the cost estimate is undesirable. And so you do a power up rate to try and improve your dollars per megawatt ratio. And then you go out to the field, finally, with paper that's really hard to change because you have a license now. And you find problems about how you can't build it the way you thought you could. And so we tried to break that down into small sprints, very near term, hardware developed, hardware focused sprints, so that we can really learn by doing, learn fast, learn cost control, and also to expose the real risks rather than kind of try to contemplate what risks might be there and then track a whole bunch of them. Some of them come to pass and some of them don't. And really, we have a great admiration for other companies that have been disruptive in their industry, like we want to be. And of course, SpaceX comes to mind as a very successful company that has completely disrupted the industry, that was very much like our industry. And you see down in the lower left, they had Falcon 1 and then the Falcon 9 Block 5, just recently completed manned flight, which is excellent. So at Kairos, we ask ourselves, what's our Falcon 1? And Falcon 1 here, Flight 4 is shown in the Marshall Islands on Omelek Island. And we think, what's similar for us? And for us, it's the engineering test unit. So the engineering test unit shown on the right, compared to our full-scale reactors, a non-nuclear, unenriched fly-wetted isothermal test that will test our vessel, including our graphite internals, fly or salt pump, pebble handling, and control elements. And it's scale relevant to both the KPX commercial reactor and to our test reactor, which I'll talk about in a little bit. And this really helps us to develop our supply chain, to practice and improve our design and testing programs, to give us experience in operations of a large-scale flight facility, and will give confidence in our ability to build, operate high-temperature flight systems. And really, so it's not really just a test of our technology and our components, but it's building muscle of our company and our people and our programs and systems, and how we can be successful in actually putting hardware into operation. So the progress on ETU is going along quite nicely. The design is just about done. Here's a pictorial. This will go in the T facility in KP Southwest, and procurement is underway for major components. So our overall development program is shown here, and you can see we have, we've done etude, we're going to the engineering test unit, non-nuclear. A new twist is that we're building a test reactor, which would be up to 50 megawatt thermal, no electrical production. That'll be on the scale of the engineering test unit. And we're doing this really to show that Kairos can deliver low-cost nuclear heat. The next sequence then is a non-nuclear U facility, which is the full scale of the commercial version of our plant, including all of the primary, which would be safety-related structural supports in the building. So this will really help us reduce that risk of going to the field and not being able to build what we had designed, and flesh that out and give confidence that we'll have build certainty. And then the next deployment would be KPX, and X meaning whatever a customer wants, 2, 4 units grouped together. So our schedule is shown here. We're in the middle of engineering test unit. We've started design of a Hermes test reactor. We've done a lot of design on the full-scale KPX So a lot of this translates to just a smaller scale. Then we'll go into U facility and then to commercial. Our intention is to have a commercial plant ready 2030 or earlier. Hermes criticality, we're targeting about 2025. U facility construction would be 2025, 2026 timeframe. So with that, I want to thank you for your time, and I think I'm pretty close, and ask if there's any questions.
You have a few questions. First, let me thank you again for providing this presentation. Again, this is very exciting, seeing the number of companies with some serious engineering capability who maybe going to be successful in this next 10 years. First question we got is, how are you synthesizing your FLIBE salt?
We've developed a relationship with Materion, who's probably one of the few providers, if not the only provider, of beryllium fluoride. We've got and we're working there to start with a pilot project to start to develop enough salt that would be available for ETU, and then we've got plans to scale that up.
Okay, how about in your T facility? Do you have plans for managing the chemical and physical hazards associated with beryllium?
Definitely, yeah. We're already we've got experience dealing with we've worked with Materion, who has incredible experience dealing with beryllium. We've put in place beryllium handling practices in our S lab at a smaller scale in Alameda. And all those things are being translated into the design of the ETU and the T facility.
And the next question we have is, what is the status for acquiring enriched lithium?
I would say, without too much detail, that we're working on that quite vigorously, and we think we have it in hand. We've got a good plan.
All right, this is last opportunity for questions. Otherwise, we're going to bring the panel session to a close. A few more seconds of opportunity. All right, I'm going to bring this to a close, and I'm going to close it by thanking all the panelists, and particularly the companies. I believe it is truly inspirational to the number of people and the attendees who have managed who sat through all this to hear the number of people who are actively working to achieve the vision. I very much appreciate that Kairos starts every one of its presentation by reminding people of its vision, and I'm fully supportive of that's a wonderful way of going. Once again, just thank you all.
Thank you, Dave.
And we're going to, therefore, since we're done and we don't need to do an audio or a video check for anything for the next time, I think we're just going to go directly into the workshop closeout and adjournment.